Hgher GCSE Combined Science Trilogy Chemistry Paper 1 Higher Tier 2021. Question 1.1. This question is about the periodic table. Figure 1 shows part of Mendeleev's version of the periodic table. Which group of elements had not been discovered when Mendeleev's version of the periodic table was published? We can see here that's group 1, group 2, 3, 4, 5, 6, 7. And we can see transition metal here. So group 8 or group 0 is missing. Group 0 or noble gases or inert gases is missing, and inert means they don't react. Noble gases don't react. Question 1.2. Which model represents the plum pudding model? B represents the plum pudding model because you got the positive charge central, which is the pudding, and the plums are the negative charge spread everywhere. So that's the plum pudding model discovered by J.J. Thomson in 1904. So the answer is B. Question 1.3. Which model results from Chadwick's experimental work? If you hear the word Chadwick, Sir James Chadwick in 1932 discovered neutron, and neutron is in the nucleus, and this is showing the nucleus here, and these are the neutrons. That's positive charge, that's proton, and it's got to be A. A, the model showing nucleus, which is positive protons plus neutron, so it's got to be A. Question 1.4. What is meant by isotopes? You should refer to subatomic particles. Because the question is asking us to refer to subatomic particles, we have to talk about protons and neutrons, because protons and neutrons are subatomic particles. So isotopes are atoms with the same number of protons but with different numbers of neutrons. Question 1.5. The table shows the mass numbers and the percentage abundance of two isotopes of potassium. Calculate the relative atomic mass, AR, of potassium. Give your answers to one decimal place. First of all, check abundance add up to 100. Then we can write AR of potassium times 100 will be equal to 39 times 93.1 plus 41 times 6.9. Now, if you add this up together, it's 100, so that's good. So to find AR, you have to divide both sides by 100. So divide that by 100, divide that by 100. So we get that. Therefore, AR, if you plug that into your calculator, AR equals 39.138. But we want the answer to one decimal place, so it's going to be AR equals to 39.1. The unit will be grams over mole, or you might say grams per mole. Either way. Question 2.1. Acids react to produce salts. Universal indicator is added to water, and then nitric acid is added to the mixture. Give the two color changes when nitric acid is added to the mixture of universal indicator and water. So we need to give the color change when nitric acid is added to the mixture of universal indicator and water. So here is the universal indicator and water, and when you add acid to it, there will be a color change from that green to red, because the universal indicator in water will show green, and then when you add nitric acid to that, it will then change to red. So we'll be going for green to red. Question 2.2. What happened to the pH of water when nitric acid is added? So the pH will decrease because it will be more acidic due to increase in acid. So this is the neutral state now where the water is with the indicator. Now when you add an acid, so acid, this is to the left of the pH. So the pH is here, or 1 or 2, you add an acid, and then what happens? It will move towards, the water will then move towards there, because you got acid, neutral here, you got neutral and acid, so it will move around here. So that's why it's going to be red. So it's going to go from the green here, you go from that green to red, and the pH will go from 7 to about 2 or 3. So the pH will decrease from 7 to 2 or 3. Question 2.3. What is the state symbol for nitric acid. So this is nitric acid, is HNO3, and it's in water. Water is liquid. You're going to get the H plus because acid donates proton, H plus, which is aqueous, plus nitrate ion, which is also aqueous. So this is water, and water is polar, and that means oxygen here is negative, delta minus, and this is delta minus, and that's delta plus, and that's delta plus hydrogen, because difference in electronegativity. And what water does is separate the H plus from the nitric acid, and that's H plus, and surrounded by the negative side of the water, because positive and negative attract. So you can see that. And then the nitrate, which is negative, is surrounded by the positive side of water. And what do we call this? We call this aqueous. Aqueous meaning surrounded by water. So this is what aqueous is. Aqueous means surrounded by water. AQ stands for aqueous. And so the symbol for nitric acid will be aqueous. So your answer would just be, because it's 1 mark, you just say aqueous. Question 2.4. Zinc carbonate, a white solid, reacts with nitric acid, an aqueous solution, to then give zinc nitrate, a colorless solution, and water, liquid, plus gas, carbon dioxide. Give 2 observations that would be made when zinc carbonate is added to nitric acid until the zinc carbonate is in excess. So first, the white solid disappears. That's the white solid. It disappeared, forming zinc nitrate, a colorless solution. That's where it's disappeared. Fizzing, bubble, and effervescence. You see that's carbon dioxide, CO2, gas given off. And then it stopped fizzing because we've used up all the nitric acid, because this is excess. So this one will be what we call the limiting reactant. So we've used it off. So no more carbon dioxide is produced. That's good. Then it stops. And what's left is the excess reagent, excess reactant. That's a white solid will be left in the system. So now this zinc carbonate is the excess reactant. Nitric acid is the limiting reactant because it's been used up. That's why white solid reappears. Question 2.5. The formula for zinc ion is Zn2+, and the formula for zinc nitrate is NO3-. What is the formula for zinc nitrate? Well, to write the formula from the ions to form a compound, this is the cation and that's the anion. We always write the cation first, then we write the anion, and we take the charge, not the positive charge, but the 2 in front of it, the number in front of the charge. We bring it to the anion here, down there, and we take the number here, which is 1 in this case, we give it to the cation. So it will become subscript. So those numbers here will become subscript for the opposite charge, opposite ion. So the superscript here will become the subscript there for the opposite ion, and the superscript here will become the subscript for this one. So now let's write this charge down. So we're going to write zinc. Well, it's 1 because this is -1, and we write the nitrate. So that's nitrate. Well, that would be 2 because the superscript here is 2. So we bring it down, or the power here is 2. We ignore the charge. All right, so we then put into bracket, because the whole compound is being referred to as twice. We don't write 1. We don't write 1 if it's 1. So we just write ZnNO3 superscript 2. So now, but we can go back and forth if we want. We can go back and forth as well. We can take the 2 back to the positive one, because the first one is always positive, so that'll be +2, and there's 1 here with -1. So this is always negative, and this is always positive. So the first ion is always positive, and the second one is always negative. So we can go back and forth between the ions and their compound. So this is the formula for zinc nitrate. Question 2.6. Acid reacts with insoluble metal oxides to produce salts. Plan a method to produce a pure, dry sample of the soluble salts, copper chloride, from an acid and a metal oxide. 6 marks. React hydrochloric acid with copper oxide. 1. In a suitable container, warm hydrochloric acid. 2. Add copper oxide until it's in excess or until solid remains. 3. Stir and filter excess copper oxide. 4. Pour solution, filtrate into evaporating dish or basins. 5. Use of water bath or electric heater to heat gently or partially evaporate. 6. Leave to cool and crystallize. Question 3. This question is about energy change. A student investigated the temperature change when 10 grams of ammonium nitrate was added to 100 centimeter cube of water. This is the method used. 1. Measure the temperature of 100 centimeter cube of water. 2. Add 10 grams of ammonium nitrate. 3. Stir once. 4. Measure the temperature of the solution every minute for 7 minutes. And question 3.1. What is the dependent variable in this investigation? The dependent variable is the variable we are measuring, and in this case, it is the temperature of the solution. Question 3.2. Give 3 improvements to the investigation to make the result more accurate. To make the result more accurate, 1. Insulate the beaker to reduce heat loss. 2. Use a polystyrene cup to reduce heat loss. 3. Add a lid to reduce or to stop matter coming in or going out. 4. Stir more to distribute heat around the water. 5. Repeat the experiment and calculate the mean while ignoring any anomalous data. 6. Use smaller volume of water. 7. Use large mass of ammonium nitrate. 8. Use more accurate balance scale. 9. Use digital thermometer or a more accurate thermometer. Because the mark is 3 marks, any 3 points is good. 3.3. Explain the results. Temperature decreases from 0 to 1.5 minutes. This is endothermic because the temperature is decreasing due to ammonium nitrate dissolving, hence taking heat from surrounding. After 1.5 minutes, temperature increases because reaction had finished and energy is transferred to the solution from the surrounding. Question 3.4. Draw a reaction profile for an exothermic reaction. You should label the energy level of the reactants and the products, activation energy, and the overall energy change. Okay, since we're looking at exothermic reaction, with exothermic reaction, the temperature will increase. As the temperature increases, the particle kinetic energy too will increase, which meant that the potential energy will decrease. Why is that? Well, potential energy will decrease because the total internal energy is equal to total kinetic energy plus total potential energy. And for internal energy is constant, and if kinetic energy increases, then the potential energy will decrease. So this is potential energy profile, and you can see we start here with a reactant, and there's a reactant starting there as 0, reactant is always 0, and this is the positive side of the energy and negative side of the energy. Because we can see from there that the potential energy is going to decrease, so the product will be here. This is a reactant and that's a product, so we draw the reactant first and then we draw the product. This is the energy path, and this energy path here, and the top here is the activation energy measured from the reactant. Always measure the activation energy from the reactant. So the height here from there to there is the energy of activation, and this is the reaction path here. And then the product is below the reactant, which is negative. So we say delta H is negative, is minus, and that indicates exothermic because exothermic is negative. And the x-axis is the progress of reaction. So this is exothermic energy profile, and the vertical here, the y-axis is the potential energy, and the x-axis is the progress of reaction. So minus delta H is the overall energy change. As you can see, we measure that from the reactant, which is 0, and down to the product, and that difference is the overall energy change. In this case, it's negative, indicating it's exothermic. Question 4. Carbon can exist in a number of different structures. The first fullerene to be discovered was Buckminster fullerene. What is the formula for Buckminster fullerene? So Buckminster fullerene is C60. Question 4.2. Graphite is a form of carbon. Explain why graphite conducts electricity. So this is the structure of graphite, and each one of these is carbon. So that's a carbon, 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 carbon. And you can see it as a top view, and the carbon are bonded to 3 other carbons. So it's bonded to 3 other carbons. The carbon is meant to have 4 bonds. So if you are a carbon, you'll be having 4 bonds because carbon is in group 4. Group 4, it means it's got 4 bonds, but in this case, it's not having 4 bonds. The carbon you're seeing here is having only 3 bonds. So you go 1, 2, 3, and the structure you're seeing here is called hexagonal structure. So this is a top view of the hexagonal structure, and it's having a spare electron. So there's a spare electron, electron there, electron, electron, not bonded. These electrons are not bonded. They are free to move because these electrons are not bonded, and therefore they are called delocalized electrons because they are free, so that they can flow around the structure from one layer to another layer. This is from the sideways. So that's the top view and that's the side view. So the electrons can flow to there and then travel everywhere and flow there. And so therefore we can say because they're carrying charge, they conduct electricity because these electrons carry charges. So the delocalized electrons, these electrons here, carry electrical charge through the structure. So they go all over the structure here. Just one extra information, that distance is d, and this distance here will be 2.5 d between there and there. So that's 2.5 d, and if this one is d. Question 4.3. Steel is an alloy of iron and carbon. Explain why steel is harder than iron. Carbon atoms have different sizes to iron atoms. Carbon atoms are smaller, iron atoms are bigger. Here is a pure iron, and this is an alloy of iron and carbon. This will be difficult to slide over each other because the layer is distorted by carbon, and the pure iron is easy to slide along each other. So carbon atoms will distort the layers of iron atoms or ions. Therefore, the layer cannot slide, and if they cannot slide, they will be much harder. So this is harder and this is weaker. Question 4.4. Iron is alloyed with carbon and other metals to make stainless steel. A stainless steel fork contains 71.92% iron. Table shows the mass of each element in the fork. Calculate the mass of iron X in the fork. So the percentage of iron is 71.92%. And the percentage of the other metals, when you add their masses, you get 16.29 grams. And if we take 71.92 from 100, we get 28.08%. So that means 16.29 grams is 28.08%. I need to find 1%, because if I can find 1%, then I can find the X grams. So 28.08% gives me 16.29 grams. So if I divide 28.08% by 28.08, well, that will cancel each other out. So that cancels that. Then I get 1. So I get 1%. I have to do the same thing here. I have to divide that by 28.08. So that's what 1% is worth. Now I need to find 71.92. So that means I need to multiply 1% by 71.92 on both sides. So to go from 1% to 71.92, I times it by 71.92. And I have to do the same here. So I'm timesing that by 71.92. So when we put that into calculator, we get X to be equal to 41.72 grams. Question 5.1. This question is about the electrolysis of aqueous solutions. Hydrogen gas and chlorine gas are produced when sodium chloride solution is electrolyzed. Question 5.1. Hydrogen ions H+ are attracted to the negative electrode. The half equation for the reaction at the negative electrode is 2H+ plus 2E- to give H2 gas. What type of reaction happens at the negative electrode? Give the reason for your answer. Well, in order to answer this question, it's good to understand oxidation and reduction. Oxidation is addition of oxygen, removal of hydrogen, loss of electron, increase in charge. Reduction, on the other hand, is loss of oxygen, addition of hydrogen, gain of electron, decrease in charge. So basically, reduction is the opposite of oxidation. If you look at this situation here, we got H+. This is the charge. And this one here doesn't have any charge. It means it's got zero charge, and this is positive charge. So I'm going from +1 to 0. I would call that decrease in charge. So that's a decrease in charge. And that's point number 1 there. So there's a decrease in charge. At the same time, I am gaining electron because if you look at the point here, I'm adding electron to that. So gain of electron is also reduction. So second thing that's happening, number 2, is gain of electron. So when we're gaining electron, we always write it on the left-hand side. And when we're losing electron, we write it on the right-hand side. So this is left-hand side. So that's a gain of electron. If you're gaining electron, that's reduction. So what's the reason? Type of reaction? This reaction is a reduction reaction. So reaction is a reduction reaction because we are gaining electron and decreasing charge for hydrogen. Decrease in charge for hydrogen and gaining of electrons. So it's a reduction reaction. So if I tick what happened here, it's gain of electron and decrease in charge. Therefore, it's a reduction. Question 5.2. Chloride ions are attracted to the positive electrode. Complete the half equation for the production of chlorine gas. So a chlorine gas is the product, and so we can write that here as the product here, so that would be Cl2. That's what a gas is. So this has to be aqueous. And in order to get those, you need, because you're going from -1 to 0, and to balance the charge, because this is -1, so if I could write it down, that's -1. And to balance the charge, you have to, this is 0 here. So if I write it down, that's 0 charge, because that has 0 there. So to balance the charge, I need to add electron, right? But I need to add electron because electron is basically -1. So for now, you got -1 here, you got -1 here. I've got 2 chlorine elements here. So I need to put 2 there because then we have to do conservation of mass. Conservation of mass is total mass on the left equals total mass on the right. So I've got 2 chlorine elements. So that's balanced. But the charge is now going to increase by another charge because there's 2 of them. But the charge is going to increase by another charge. It is 2 of them. It is therefore it's -1. Altogether, I've got -2 here, and therefore I need to multiply the electron by 2 to get another -1. So that will be -2. There's 2 electrons here. So this is -2 electron. Those are the charge of the 2 electrons. Overall is -2. So what I've done is I've balanced the charge on the left-hand side. So in chemistry, we balance mass. We call it conservation of mass. We also balance charge. We call it conservation of charge. The total charge on the left equals to total charge on the right. And that's good. So that's balanced. So now that that's balanced, we can drop that off. And now, so this is the equation we're looking for. We can actually write it properly by saying 2Cl minus, that's aqueous, going to 2Cl gas, Cl2 gas, plus 2 electrons. So this is the half equation complete. The reason why we call it half equation complete is because it's only involving one atom and the other atom is not included. And this is what we call oxidation because electron has been added to the right. If you're adding electron to the right, that means this is losing electron and that's oxidation. So this is oxidation. And also the charge is decreasing from -1 to 0, -1 to 0. So that's an increase in charge, not decreasing, increase in charge from -1 to 0. So if you're going from -1 to 0, the arrow is going to the right, that's an increase in charge. So what do we have? We have increase in charge because we're going from -1 to 0, and we have also loss of electron. So because we are losing electron, the electron was here, now we've lost it. That's why we got the 0 charge instead of minus. And this is both oxidation. Here we can see that's oxidation. So we have increase in charge and loss of electron. Reaction is oxidation. Question 5.3. Hydrogen gas and oxygen gas are produced when sodium sulfate solution is electrolyzed. Explain how oxygen gas is produced in the electrolysis of sodium sulfate solution. Water is dissociated, that means breaking down, to H+, that's a proton, plus OH minus aqueous, and that's proton aqueous as well, so that's hydrogen ion. At the anode, the SO4 is negative, so it's attracted to the positive, so therefore this is called anion because it will move to the anode. So this is anion because it will move to the anode, hence it's the ion that moves to the anode, anion. And as it moves to the anode, it would release 2 electrons. When it releases 2 electrons, this is what it will form. After releasing the 2 electrons, the electron will flow through the wire, so that's a flow of electron in that direction and in that direction, and then it comes to that direction there, and then the electron will come to the cathode, and when the electron gets to the cathode, it will be picked up by hydrogen ion. So at the cathode, as the electron flows through there, they'll be picked up by the hydrogen, and that's what happens. So the hydrogen is collecting this electron. So one hydrogen collects 1 electron, another hydrogen collects another electron. So 2 of them will form hydrogen gas, and the gas will be released. Also, at the anode, the OH ion will be attracted to the anode because, again, this is another anion. So it will be attracted to the anode. Anion is ion that moves to the anode. Because it's attracted to the anode, again, it will release the electron. And as it releases the electron, the OH itself will then react with another OH to then form H2O plus oxygen. And this oxygen will then react with oxygen to then form oxygen gas. Again, that will be released. So now remember, we've got 2 OH forming here, 1 OH, another OH, and that meant that you will have got 2 there and 2 there and the 2 electrons. So altogether 4 electrons are released, and you can see from here 2 electrons there and 2 electrons there. Altogether 4 electrons have been released, and therefore you get the oxygen gas given off and the hydrogen gas given off from the electrolysis. So the movement of the ions are very important here. That going to there to release electron, and the electron flows along. That also goes there to release electron. Electron flows along, and the OH produced now reacting together, and also the hydrogen receiving an electron here to then form hydrogen gas. Question 6.1. Metal oxide are produced when metals are heated in air. A student investigated a change in mass when 0.12 grams of magnesium was heated in air, as shown in the figure. The student measured the mass of magnesium oxide produced, and 0.12 grams of magnesium reacted to produce 0.2 grams of magnesium oxide. Calculate the number of mole of oxygen gas that reacted. Here's the reaction. That's magnesium solid plus oxygen gas reacting to give magnesium oxide. The stoichiometric mole here is 2, 1, and 2. So mole equals mass weighed divided by molar mass or relative molecular mass. N for mole, little m for mass weighed, and capital M subscript R is the relative molecular mass or molar mass, and that is 0.12 grams divided by, because oxygen is 16, there are 2 oxygen here, so that's 32, so divided by 32 grams per mole, because the mass from periodic table is grams per mole, and therefore when you divide those two together you get 0.225 moles, and that can be written as 2.5 times 10 to the power minus 3 mole in standard figure. And note that the unit, the grams, cancel grams, and you get 1 over per mole, and that equals to mole. So that's the answer that we're looking for here. Question 6.2. The student repeated the experiment without a lid on the crucible. Suggest why the mass of magnesium oxide produced would be different without a lid on the crucible. Without a lid, that lid over there, if we take that off, the mass of magnesium oxide, the products left, will be less because some products may escape. Question 6.3. Copper reacts with oxygen to produce copper oxide. And we've got 63.5 grams of copper produce 79.5 grams of copper oxide. Calculate the mass of copper oxide produced when 0.5 grams of copper reacts with oxygen. Give your answers to 3 significant figures. First thing to do is to apply conservation of mass, which means we need to balance the mass. The total mass on the left has to be equal to total mass on the right. I can see I've got 1 copper here and 1 copper there, and I've got 1 oxygen here and I've got 2 oxygen. So the first thing I should do is to place 2 here, and that 2 then meant I've got 2 oxygen. Now I've got 2 copper. Because I've got 2 copper, I will have to multiply that by 2. And so that will be 2. Now the total mass on the left equals total mass on the right. And that's conservation of mass. So the next thing I need to do is write down what I'm given. Used is 63.5 grams, and the mass of copper oxide made is 79.5 grams. Okay, so now I've got 63.5 grams. I need to find 1 gram. To find 1 gram, I need to divide that by 63.5. Because if I divide it by 63.5, I get 1, and that's 1 gram. And if I divide that by 63.5, I need to divide the other side of the equation by 63.5. So I divide that by 63.5. Now, after that, I need to find 0.5. Now that if I know 1, then I can find 0.5. So all I need to do is multiply that by 0.5, and that will give me 0.5 grams. So I need to times this side as well, which is 79.5 grams divided by 63.5. That shouldn't be grams. Then just divide it by 63.5. Obviously, I need to then times it by 0.5. So that would be the mass of copper oxide produced when I've used 0.5 grams of copper. Because that's what the question is asking, is to calculate the mass of copper oxide produced when 0.5 grams of copper is used. Here, we've used 63.5 grams. We got that amount. And if I divide 63.5 by 63, I will get 1 gram. Good. I have to divide that 2 by 63.5. And then to get 0.5 grams, I need to times it by 0.5, and that gives me 0.5 grams. I need to times that 2 by 0.5. Now if I plug that into the calculator, we should get 0.625 grams. That will be the mass of copper oxide that will be produced when 0.5 grams of copper is used. It will produce 0.625 grams of copper oxide. Question 6.4. Iron reacts with oxygen to produce an oxide of iron. 0.015 mole of iron reacts with 0.01 mole of oxygen gas. determine the formula for the iron oxide produced and the balanced symbol equation for the reaction. Okay, so this is what we've got. We've got iron solid with oxygen gas. So if I put a gas there, it's G. And then they're producing iron oxide. We don't know what X is. We don't know what Y is. We need to find that. But we're given the mole. And the mole for this reaction, so if I put N here, and the mole for that one, for iron, is 0.015. And the mole for oxygen gas is 0.01 mole. If we know the mole, we always divide it by the smallest whenever we're trying to find the formula. So the smallest is 0.01. So I'll divide that by 0.01 and divide that by 0.01, and the 0.01 will give me 1 to the ratio of 3/2. That is 1.5. So this is 1.5 and this is 1. All I did was always divide it by the smallest. And this is for iron, but that is for oxygen gas, if you use O2. Or we don't like fractions, so we multiply both sides by 2 to get rid of the 2 in the denominator here. So I'm going to get 3 because the 2 here we cancel out 2, and I'm also multiplying that one by 2, so that would be 2. So the ratio is 3:2. So for one iron, I've got 3 irons, and I've got 2 oxygen gas, so I've got 2O2. So that's what the ratio is telling us. And so I've got 3 ions and I've got 4 oxygen atoms. So here I need to put in here the compound we're getting out will be Fe3O4. So Y is 4, X is 3. So the structure for this compound, if I look at the charge for this compound, it's actually quite a difficult one, because you see that iron is going to be, iron has to be 2 different types of iron. It's going to be here, and we're going to have +2 iron and +3 ions. And then we're going to have oxygen is 2 minus, so that'll be 0, 2 minus, and that's 4 of them. So if you 4 times -2 is -8, because the whole charge has to be 0. For iron, 3 plus will be 2 of iron 3 plus, so that'll be, let's stick 2 there. So 2 times +3, that'll be 6. That's 2 times +3, and that'll be 6. And this one will be +2. So altogether, I've got +2 + 6 - 8 equal to 0. So that's what's happening. I've got 2 iron, 1 iron 2 plus, and 2 iron 3 plus. This is a difficult one. This is more like, I recognized that when I was doing my degree in chemistry. So, but the structure for this one, iron bonding to oxygen, bonding to iron, and this one is also bonding to oxygen, and then iron, and then we got maybe iron to oxygen there, and then oxygen to iron, and then again iron to oxygen, then oxygen to iron. So that is the structure. This is a complicated structure, but the simplicity here is that it's a ratio thing. Again, you just divide it by the smallest and you find your ratio 1.5 to 1, but we don't like 1.5, so we have to multiply the whole thing by 2. We get 3 to 2, and you can see 3 atoms there for iron and 2 for oxygen gas, which means is O4, and that's how you stick in there. So what chemical formula we're looking for is that one. Now to balance the equation, I need to replace X here by 3 and 4, which means I need 2 of those and I need 3 of those. And now the equation is balanced. So that is the balanced equation. Question 7.1. Methane, ethane, propane, and butane all react with oxygen to produce carbon dioxide and water. This is combustion. Suggest why a mixture of methane and oxygen does not react at room temperature. Answer in terms of particles. So particle will have to collide and then follow the reaction path. And if they haven't got enough energy to go from there to there, then the reaction will not go. So it would stay here. So at room temperature, those particles have not got enough or insufficient energy to collide to overcome the activation energy. So therefore, it have less energy than activation energy. So collision are not successful. So this collision will not be successful. They will be colliding, but not enough to give them the energy to go over all the way to form the product. So that's what this is saying. So this is what you have to say, is that particle collide, but at room temperature, particles have insufficient energy to collide. It have less energy than activation energy, so collision are not successful. Question 7.2. Table 3 shows the energy released when methane, ethane, and propane react with oxygen to produce carbon dioxide and water. Predict the energy released when butane reacts with oxygen to produce carbon dioxide and water. So this one is a tricky one because the difference between this energy and that is 480. And the difference between that and that is 480. And the difference, and therefore I need to add 480 to that to get that. So basically that's what you need to do. Well, if you look at the formula, the difference between the two is CH2. And the difference between that one is also CH2, and the difference between the next two is CH2. So that's why probably the difference in the energy is the difference corresponding to that value here, which is CH2. And that is also corresponding to CH2, and that's corresponding to CH2. Maybe that's why that difference is the same. So the predicted energy for butane will be 2,120 kilojoules per mole. Question 7.3. Propane reacts with oxygen to produce carbon dioxide and water. The display formula equation for the reaction is given here. And the reaction is exothermic. In the reaction, the energy released when forming new bond is 1640 kilojoules, greater than the energy needed when breaking bonds. The table here, Table 4, shows the bond energies. Calculate the carbon-carbon bond energy X. Okay, now what we need to do is we need to work out the bond breaking and bond making. The bond breaking is we need to break reactants bonds because we're reacting them together. So we have to break the bond and then mix them again and make a new bond. So we need to work out how many bond of carbon-carbon bond. I can see it's 2, 1, 2. How many bond of carbon-hydrogen bond? You can see carbon-hydrogen bond. It's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. You can see 5 oxygen bond. When we balance the equation, we need 5 of them. So look at oxygen bond. We need to break that too. So 5 of those. So here are the bonds. The carbon-carbon is X. That's what we're looking for. 2 times CC bond. CC bond is X, so that's 2X. Now we're looking for the X, but this is the carbon hydrogen, and that's the reason why I'm putting positive there because we're breaking that bond. This is endothermic. Reactants, when you're breaking reactant bond, it's always endothermic, so that's why it's positive. Now we need 5 oxygen bond to break. That's why we get that. Again, it's plus because breaking bond is plus, making bond is negative. We're not making any bond yet, we're just breaking it. And then we're going to react them together to make a new bond. This is the exothermic because we're making a new bond and they will be negative. So we got 3 times 2 CO bond. Well, we got CO bond here, 1, 2. There's 2 of them and times it by 3. So 1, 2 times 3. That's why we got 6, 740 because CO bond is 740. Water has got OH, 2 OHs, 1, 2 times 4. So that's why it's 4 times 2 OH, and that's 8 times 460. OH is 460, and we get that. They are negative. When you're making bond, products always negative. The bonds of products is always, you always make them as negative. Products are exothermic, reactants are endothermic. They're positive, and products are negative. Okay, so now the question then said, when we add the bond breaking and the bond making, we get this. We get minus 1640. Why minus? Because the question says it's exothermic, and exothermic is always negative. So you have to put minus there, and you have to put equals. So now what we need to do is that plus that, plus that, plus that would be equal to that. So plus that as well, don't forget, and we're looking for that. So now we go to 2x plus 3280 plus 2500 minus, because it's minus, 4440 minus 3680 equals to that. X, the subject, I need to take all these one to the other side, and the sign will change, and then I need to divide it by 2 to get x. So now, all I did was, that was there, and I moved that to there. I move all those to there. That minus here, if I move them to there, they will be plus. That's why they're plus here. Because when you cross over to the other side, your sign will change. And this one is positive here. it will be negative if I go there, so that's why it's negative. That's positive here, it will be negative when we go there, that's why it's negative. And I need to divide everything by 2. X stay there, so that's X equals to that. And that add up to 700 over 2, which is 350. So the value for X is 350 kilojoules per mole, or 350 kilojoules over mole. And so therefore it goes in the 350.